How's it going, everyone? Recently, I bought a 3D printer and I've been playing around with it for quite a bit. So today I thought it's a good idea to get started with learning how we can model 3D objects in Python. And this will be the first episode of a series. Right now I'm using Zed, the code editor, along with OpenSCAD to model things, such as this little train. And that's what we're going to be learning how to create in this video. Now, before we begin, I'd just like to thank Zed for sponsoring this video. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding for a while now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. Now, the first step is to go to OpenSCAD.org and download OpenSCAD. This is free software and available for Linux, Unix, MS Windows, and Mac OS systems, and is what we'll be using to generate 3D objects in today's video. And since we're going to be doing all of this from scratch, I'm going to remove this side window. But after you've downloaded OpenSCAD, the next step is to open up a dedicated code editor. Again, I'll be using Zed for this tutorial because I think Zed is awesome and I love using it to do all my coding, but you can use any code editor you wish to use. If you are using Zed, I'd recommend going to the extensions settings and looking for OpenSCAD and downloading the language support. Because what we're going to be doing is writing Python code which translates to the SCAD language. And there will be moments where you might want to edit the SCAD code directly. So it's just nice to have that language support. Then you're going to want to open up the terminal, clear it, and either pip install or uv add Python, or not Python, but solid Python 2. Since I've already installed this, it's going to be instant. And before we continue with creating the train, we're going to create a normal cube. This is important because it will tell us whether we've installed everything correctly. So here let's import solid 2 as sp for solid Python, and from solid2.core.objectbase we're going to import OpenSCAD object. Now the typing for solid 2 is quite weak and not well supported, but I'm still going to do my best to type everything. And the first function we'll create is called buildModel, and this will return an OpenSCAD object. Then we will return an sp.cube with the dimensions of 20, 20, and 20. And we want to make sure that this cube is centered. And as always, I'll create my if name is equal to main check along with the main entry point and start off by creating a project name, which will be of type string. And this will be called train.scad because ultimately I want to create a train here. Then we will define a model, which will be an OpenSCAD object. And here we will build a model. Or build the model, which at the moment is just a cube. And we want to save this model, so model save as SCAD, and we will pass in the project name, which is also the file path. And at the bottom, we will print that we successfully generated that project. Next, we're going to run this, and hopefully, if we set up everything correctly, it will give us this success message, that we successfully generated train.scad. Now it's time to locate that file. And at the moment, you can ignore this part here. That's actually the tutorial I'm recording right now. I write everything out ahead, so I don't make that many mistakes. And the live output.scad, that's irrelevant. What you want to look for is train.scad, the file you just generated. And here you want to reveal it in the Finder. And once you find that file, open it with OpenSCAD. And what you should end up with is a screen like this one. Now the theme is probably going to be different for you because I spent a good 5 minutes seeing how I could customize this to get dark mode, and I ended up with this dark mode. Otherwise, what you should see is a cube in this software. And this is a cube we generated from Python. Now here we're going to click on X because we don't care about that message too much. And we're going to enlarge the object screen. Then we're going to open up the toolbar. And here what you want to do is click on View. That's absolutely false. We wanted to click on Design and toggle Automatic Reload and Preview. This will make sure that every time we make a change to this file, it updates the cube. And at the moment, this is SCAD code, not Python code. I might end up making some dedicated tutorials to the SCAD language because it's quite simple to use and might even be easier to create things with than Python if you're creating something quick. But since this is a Python channel, I'm going to do my best to make Python as relevant as possible. And hopefully that means speeding up the development process when it comes to creating cool objects. Anyway, we're going to close this sidebar. And what I like to do on Mac, and I'm sure you can do the same thing on Windows, is grab this window and create a split screen view. Then I move this all the way to the right and close all the bottom boxes until I have a full cube. And to make sure that everything's working, we're just going to run our script. But of course, we should change something here so we see the difference. So I'm going to change Y to 40 and run our script. If you set up everything correctly, you should now have a nice stick of butter. And yellow is the default color, but I'll show you how you can change that later inside the script. Anyway, now that we have our object, we can start creating our train. And the very first thing I want to do is import from data classes the data class, because I want a data class which controls the size. What you should know is that in this program, X translates to the length, Y translates to the width, and Z translates to the height. And of course, you can keep these as X, Y, and Z if you find that to be more readable, but personally, I like to have these human readable names. Below that, we're going to create a function called rounded cube. Of course, we could have created a train with regular cubes, but there's no fun in that. I want to show you how you can create rounded cubes. And this rounded cube will take a center boolean, a size of type size, a radius, and a number of fragments. And this will control the smoothness of the rounded particles, or the rounded segments. If Fn is set to something low, the rounded sides are going to look like hexagons. But if you set this to a high number, it's going to look ultra smooth. And this will return an OpenSCAD object. Then below we will return sp.minkowski. And this will generate the Minkowski sum. And I can't go into too much detail about the Minkowski sum because I don't know that much about it myself, but all you need to know is that this will sweep the sphere around the cube to give it its round edges and corners. Then inside we will create an SP cube, which will consist of these three dimensions. The size.length minus 2 times the radius, the size.width minus 2 times the radius, and the size.height minus 2 times the radius. And below we will set center to true. And this should not be inside Minkowski. We actually need to create another pair of parentheses. Then under this, we need to create a sphere that holds the current radius and the fragment number. And this argument makes much more sense if you know the SCAD language, because there you'll be using Fn quite a bit. Anyway, now we have a function which rounds a cube, or returns a rounded cube. Now we can go back to the build model function. And here we're going to return sp.union, which combines shapes together, and then we can include each shape inside here. At the moment, we don't have any shapes to include, so we will start off by creating our base cube, which will be of type OpenSCAD object, and this will equal a rounded cube, which will start by taking center, which will be set to true, a size, which will be set to a size with the dimensions of 50, 20, and 20. The radius will be set to 2, and Fn will be set to Fn, which is something we still need to create up here. So Fn here will be of type integer, and we will set the default to be 100. Now we can return the base cube inside sp.union. And just to make sure that everything is working correctly, we're going to rerun our script. Now we have a proper rounded stick of butter. To stop this from looking like a stick of butter, I'm going to translate this, or not translate it, but change the color of it to white. And now the stick of butter is white. Anyway, next we can create the top cube, which is where the conductor will live and drive his train every day. And inside here, we're going to open up another pair of parentheses and type in SP cylinder, because we want to create a cylinder shape. with the center set to true. And that just makes sure that the initial position of the cylinder is directly in the center of this X, Y, and Z axis. The height will be set to 10, and the radius will be set to 5, with an Fn set to Fn. And we're going to subtract another cylinder from this. So we're just going to copy and paste that. And all we're going to change here is the height to 20 and the radius to 3. And below we're going to call .translate, and we want to translate it on the x-axis by 15 millimeters, then by 0 on the y-axis and 15 on the z-axis. And below we will change the color to light blue. When we render the object, it's going to be completely black because I do not have any blue filament. But it's still cool to be able to design something with different colors. Then we can add the top cube to the base cube. And you know what? This was not the top cube. I actually created a cylinder here. So instead of rewriting all of this, we're just going to change this to a cylinder. That was my bad. I copied the wrong section of the tutorial. This creates a cylinder, not a top cube, as you might have guessed by these cylinders here. So now we have a base cube and a cylinder, which means we have a place for the exhaust. And all we're missing is a compartment for the conductor. So now let's create that top cube, which will be of type OpenSCAD object. And preferably, I'd have this above the cylinder. I want my cubes to be together. And this will equal another rounded cube. So we're just going to copy this part here and paste it here. Except this time, we're going to set the dimensions to 22 by 18 by 18. And we need to wrap this rounded cube in parentheses so that we can perform method chaining. So here we can add translate in front of color, and we'll add -13 on the x-axis, 0 for the y-axis, and 15 on the z-axis. And all we need to do now is add the top cube down here. And the next time we run this, we'll end up with this train, which is quite cool. Although I might make the top cube light blue as well. And that's actually the whole project. Now let's make some more room on the OpenSCAD window. And I'm actually going to minimize it so I can just use it as a normal program. And here we're going to learn how we can export this. At the bottom, I've changed the toolbar to include 3MF, which seems to be compatible with most modern 3D printers. But to set this up, you need to go to your preferences, and this will open it up in a separate window. And while we're here, you can change the theme of your editor in the editor section. So if you want to have a dark mode, I'd recommend Tomorrow Night. Otherwise, we can go to, I believe it was advanced. And if you scroll all the way to the bottom, you'll see some export features. So depending on what you want, you can select it from this menu. For me, I think 3MF works perfectly fine, so I'll leave that as is and close my preferences. Now inside the software, you can either click on 3MF or you can go to Design, click on Render, make sure that everything's rendered, and then go to File and Export. So here you have all the options for how you want to export your object. In my case, I want to export it as a 3MF file. And for simplicity, I'm just going to save this in my desktop. Next, you're going to want to find the file you just downloaded and open it up in whatever software you use to render your projects, or to make sure they are print ready. And as a result, you should end up with a train like this one. And since I'm using Bamboo Studio, when I open up the project, it will look like this. And if we look at the dimensions, you'll see that it is 50 by 20 by 34. And in your software, you can shrink it or you can make it bigger. It really depends on how big you want your train to be. From what I understood, the units that we just used in our code editor translate directly to millimeters. As you can see here, we have 50 millimeters by 20 millimeters by 34 millimeters, with a slight imprecision, which we could probably fix in the software if it's that important. But yeah, as an output, you should get this cool train. And even if this was a very simple project, it's the first project you created. So you should feel proud about what you've done here. And again, this was the first episode of the series. So we will start creating much more advanced objects down the line. Because while this train is cool, it's still very simple and doesn't really do anything. And I mean, These sharp edges on the exhaust pipe, or whatever you call it, doesn't look that good. Maybe we want to be able to round it at an angle. And maybe we want the front of this train to be rounded as well, instead of being a stick of butter. We're just going to learn all of those things as we progress through this series.